question says that the number of flaws in a plastic panel used in the interior of automobile has a Poisson distribution. What has a Poisson distribution? Number of flaws. It has a Poisson distribution. And the mean is given, lambda is given with mean of 0.5 per square meter. We might play around with lambda, units of lambda also. Like we give you per square meter and ask you a question about per 5 square meter or per 10 square meter. But that's not the core of this question. Assume that the automobile interior contains 1 square meter of plastic panel. What is the probability that there is no surface flaw in that 1 square meter? There is no trick of units here. Lambda is given in what units? What units? Per square meter. And the question is per square meter. So don't worry about the units. The trick is in part B. So let me first solve part A, because in exam, we might give you straight away part B without part A. Okay. Let me do that. Now look at the question. It will give you a different look. The question says that if 10 cars are sold, what is the probability that none of those 10 cars, they will have any surface flaw? Any idea about anything about this question? Let me repeat the information. For any car, single car, the number of flaws in the car follow a Poisson distribution. Okay, for any single car, the number of flaws, they follow a Poisson distribution with lambda equals 0.5 per square meter. Okay, you select 10 cars and you have to find the probability that all of these 10 cars, they have no flaw on them. What is the question? What is the variable? Where is the interest? If 0.5 is lambda, then what is this 10? This is not T. If I ask you a question about 10 square meter, that's T. If I ask you a question about 10 square meter, that's T. I'm asking you about 10 cars. Or let's say another example. I'm making the copper wire, and the number of flaws per meter of the copper wire is, let's say, 0.5. Okay. And I ask you a question that I have selected 10 pieces of copper wire. What is the probability that all 10 of those, they contain no flaw or 1 flaw or 2 flaw or any number of flaws? Now the question is going to become a little easier when I unhide part A. First, let us solve part A. Part A says what? Forget about part B now. For instance, now look at part A. What is the probability that there is no surface flaw in an auto's interior? Read the question and look at part A. Question says that in auto interior, the number of flaws, they follow a Poisson distribution. So X is number of per square meter. And we know that X follows what? With lambda equals 0.5, correct? What is required in the question? Part A. X equals 0, simple. Probability that X equals 0. This is what? E to the power minus lambda, lambda to the power 0 over 0 factorial. I just plugged in value 0 into the mass function. Somebody tell me e to the power minus 0.5. Calculators. e to the power minus 0.5. Oh, I have it here. I have solved the question. 0.6065, right? Right. What is this 0.6065? It's the probability of any car not having any flaw, correct? Now, what's part B? If you select 10 such cars, what is the probability that all 10 of them are successes? 10 cars, you select 10 units like this one now. Before you were talking about 1 unit. Define another variable y, which is number of cars not having any flaw out of 10. Are the cars independent of each other? What is this? This is success. Sorry. This is success. Not having any flaw is actually a success. And the probability of success, you found it. It was not given to you. You found it using Poisson. What was that probability? What is n? What is required in part B? Now read part B. Where is
10 car does not have.
You select 10 cars and all of them, they have no flaws. That means all 10 of them are successes. So what is required? Y equals 10. X is Poisson. Y equals 10. What if I ask you a question? Look at part C. Now, C would look simple. If 10 cars are selected, give me a minute. Give me a minute. If 10 cars are selected, what is the probability that at most one car has any flaw? Is this in terms of X or in terms of Y? Question. Y. What is required? At most one is what? One or less. So probability Y equals 0 plus probability Y equals 1. Yes. Now.
Part B that we not consider that saying 10 cars are sold. This means 10 meters.
No, 10 cars are not 1 meter cars.
It says that assume an automobile contains 1 square meter of plastic. 10 cars has 10 square meters.
What if I ask you this question? Can you do the same way? Part C.
Part C. No.
You cannot do this. So you have to generalize. For this one, yes.
B.
Part B, yes. Yes. See. For part B, it's 0.6065 to the power 10, right? And the way you are saying, it will be e to the power minus 10 times. What was lambda? 0.5. It is actually e to the power minus 0.5 whole to the power 10, right? Which is actually the same as this one. It will work for part B both ways, but for part C, you must convert it to Y. So the point here is sometimes we give you a question from binomial distribution and the probability of success P is coming from another distribution or maybe even binomial distribution. Maybe even hypergeometric distribution. Let me give you another example. I have many sections of 35 students. Many sections of 35 students. Okay. Each section has this formation. 13 from mechanical engineering. And what is 35 minus 13? 22 from non-mechanical engineering. And from each section, I will pick, let us say, 3 students. Okay. What is the probability that I will select 5 such sections? What is the probability that 2 of the sections have at least 2, or let's say 3 mechanical engineering students? No, not 3. I am selecting 3. Let me select 6. So I have a section of 35 students. I will select 6 students. What is the probability that at least 3 of them will be mechanical? You can find that. With what distribution? I'm selecting 6 without replacement from a finite population. What is the distribution? Hypergeometric. You can find it for one section. The probability of having at least 3 mechanical engineering. Then I'm saying that I'll go across sections, many sections, from section to section. What is the probability that if I select how many sections? Let's say if I select 5 sections. I wrote it. Select 5 sections. What is the probability that 2 of those 5 sections will have at least 3 mechanical engineering in the 6 selected students? Now here, there are 2 variables involved. X is the inner variable within section. What is that? X is number of ME students out of 6 selected. And Y is number of sections having greater than or equal to 3 selected ME students. 2 variables involved. One within, one outside. First, talk about within X. Find the probability that for any specific section, if you select 6, there will be at least 3 mechanical engineering students. So what is that? Greater than or equal to 3? Hypergeometric. How do you find that? Let me make it easier. At least 1. How will you find that? Complement 1 minus. So it is 1 minus K combination X. How many mechanical engineering students do you have in the section? 13. How many do you want? 0. Remaining 22. Total number of selections is 6 from each section. 35 combination 6. You will have the answer to this one. Can someone give me the answer to this one? Final answer, 1 minus after 1 minus 0.954. So this is actually the probability that any section will have at least 1 ME student among 6 selected. Correct? Now I will select 10 such sections. Section 1, Section 2, Section 3, Section 4, Section 5, Section 6. And I want to see that how many sections they have at least 1 mechanical engineering student among the 6 selected students. So I'm doing what? N equals 10 and P equals this one. And my Y follows now binomial with N equals 10 and P equals. And my question is that out of those 10 sections, let's say 3 of them, they have at least one mechanical engineering student selected. So this is Y equals 3. This is 10 combination 3, P to the power 3, 1 minus P to the power 10 minus 3. This is the toughest level of question you can expect in exam, where we give you a question for binomial distribution and we do not give you the probability of success directly. We ask you to find the probability of success from another distribution. Any question? Another possible trick. All the 3 questions that I bought from chapter 3 are A+ questions. Another one is 155C. C. Again, a very tough question. Traffic flow is traditionally modeled as a Poisson random variable. A traffic engineer monitors the traffic flowing through an intersection with an average of. It is given that the distribution is Poisson. It is given that 10 cars per minute. To set the timing of a traffic signal, the following probabilities are required. What is the probability that no car passes through the intersection within 30 seconds? What is the trick in this question? Units. The lambda is given per minute and the question is per 30 seconds. So for part A, you have X, which is number of cars passing per, let's say, minute. So X follows Poisson with lambda equals how many cars? 10 per minute. And the question says, A part, no car passes 0, but per 30 seconds is how much minutes? Half a minute. So this is e to the power minus lambda times t to the power 0 over 0 factorial. And this one gives me what? I don't know, but something. It will give me something. Look at part B. What is the probability that 3 or more cars pass through the intersection within 30 seconds? Similar to this, you will solve this one. No trick again. The main thing is part C. Read part C and tell me if you have any clue what to do. Put the mobile in the pocket. This is week 5 and I have won many times, all of you. Read question part C and see if you have any clue. You have to find the number of cars passing through the intersection. What is the notation that we gave to the number of cars passing through the intersection? X. So you have to find the value of X. Till now, 99% of chapter 3, we were giving you the value and asking you for the probability, either equal to probability or less than probability or greater than probability or less than equal to or greater than equal to. This is opposite. We are giving you the probability, which is 0.9, and asking you for the value. The only question here is, what probability are we giving you? Are we giving you equal to or less than equal to or greater than equal to, or what kind of probability are we giving you? Calculate the number of cars through the intersection. So the probability of this number or fewer cars. This number or fewer cars. So what are we giving you? We are giving you less than equal to probability to be 0.9 and asking you for that value. This is actually a question of percentile. From probability distribution perspective, we are asking you for the 90th percentile. 90th percentile is the value for which less than equal to probability is 90, correct? 90th percentile. We're asking you for the 90th percentile. So for any percentile, this is general for chapter 3 whole. For any percentile, percentile can only be found through CDF. Percentile can only be found through CDF. Only through CDF. So you need CDF. What is CDF? Less than equal to probability. So you need to create a table of X. What are the values of X which are possible for Poisson? 0, 1, 2, all the way. You have the functional values in the formula sheet, correct? E to the power minus 0, 0 lambda to the power whatever. From this one, you need to create f of x. And you need to see where this f of x is first time hitting 0.9. And the corresponding value of x is a. You get the point? I will show you now. Because this is a lot of calculation, I will do it in Excel. So the calculation will be automatically done. In the exam, we might give you a smaller question. Maybe there are 3 or 4 values of X, not from Poisson, but another distribution. From calculator, yes. But pay attention to the concept. Here for X, the possible values are 0 all the way up to, I will select like up to 20. I believe up to 20, I will find the percentile. And f of x is given to me in the formula sheet. It is e to the power minus, my lambda was what? Half? 5. 5, 10 by 2. It is per 30 seconds, right? Per 30 seconds. So lambda is 5. E to the power minus 5 times 5 to the power x over x factorial. Right? I have the PDFs. How to find the CDFs? Sum all the way downwards. This plus this is this plus this is this. Sum of these 4 is this. Sum of these 5 is this. Right? This is my CDF. Where is this CDF hitting 0.9 for the first time? Here. Can you see it? Let me highlight it for you. Can you see it? So this is the value of A. What is the value of A? 8. And 8, you can call it to be 90th percentile, actually. The question was asking you for 90th percentile. So you just have to solve this equation indirectly, create the CDF column, and see where the CDF is hitting that probability. What if the question asks you for the median? What is the median of X? Where is the CDF hitting 0.5 for the first time? 5. What is Q1? 3. What is Q3? 6. So you can find any percentile from CDF. Keep in mind, Now I'll tell you a key. Keep in mind, there are few things that can be found using both of these columns. Probabilities can be found using both of these two columns. There are few things that can be only found through this one. What are those? Mean, variance, standard deviation. You cannot find mean, variance, standard deviation from this column. You need the first one. So if there is a question where we give you this and ask you for the mean, what are you supposed to do? Come back to this. By taking the successive differences, come back to this one. You cannot find the mean using this column. If we ask you for a percentile, percentile cannot be found through this column. So if we give you the PMF and ask you for the percentile, must compute the CDF, then only you can compute the percentile. So the probabilities can be found through both of them. We did that in our examples. Probability, whether it's equal to probability or less than probability or greater than or less than equal to or greater than equal to, all of them can be found with both. I'll show you now with the example how can we find it with both. But percentile can only be found through column C, and mean, variance, standard deviation can only be found through column B. If opposite is given to you, first compute the corresponding column, then you can only find the respective measure that is asked. A small example, and then I'll move on towards the next question. What I said is that probabilities can be found through both functions. How? Look here. Suppose I have x 0, 1, 2, 3, and 4. F of x is 0.1, 0.2, 0.2, 0.3, and 0.2. Is it full, complete? 2, 2, 2, 3, 1 full. F of x added downwards 0.1, 0.3, 0.5, 0.8, and 1. I ask you a question, find the probability of x equals 2. How can you find it through PMF? It is simply f of 2. Okay. How can you find it through CDF? This is, I will write it in a new line. It is capital F of 2 minus capital F of 1. This minus this. Both can be used, correct? What if I ask you for probability x less than equal to 2 using PMF? F of 0, F of 1, F of 2. Using CDF? Simply F of 2. What if I ask you for probability of 1 less than x less than equal to 3? Using PMF? Using CDF? What if I ask you for probability of x more than 2? F of 3 plus F of 4. What if I ask you to use CDF? 1 minus F of 2. And you can manipulate with any probability question to find the probability using any of these two. But mean cannot be found. Mean, the only formula for mean is summation x times f of x. Cannot be found through capital F of x. And any percentile let me call it PI, you must solve this equation. You must solve this equation for PI. For example, you are interested in P75. So f of P75 equals 75 over 100, 0.75. Solve this equation for P75. So any percentile cannot be found through small f. Mean, variance, standard deviation cannot be found through capital F. Probabilities can be found through both. Let us have one more question. 176. This is a little easier than the two we discussed before because this is not much complicated. At the end of the previous class, we discussed a case where X was Poisson distribution and lambda was not given to you directly. Do you remember that? I gave you the probability of X equals 0 and asked you to find lambda from there. X was not given to you directly. Lambda was not given to you directly. Instead, here, we tell you that X has a Poisson distribution, but we don't give you lambda. We tell you that probability of X equals 0 is 0.4. This probability X equals 0 is what? E to the power minus lambda, lambda to the power 0 over 0 factorial, correct? So solve this equation indirectly for lambda, and you get lambda from here. And then we might ask you a question, what is the probability that X is 1? So you plug in that one, right? Similar kind of situation can happen with binomial distribution, where we don't give you the P. We give you some probability and you have to solve indirectly for the value of P. Look at this question now. Look at 176. It is suspected that some of the totes containing chemicals purchased from a supplier, they exceed the moisture. So X is the number of totes that exceed the moisture content target. How many samples are you selecting? 10 samples. So your N is 10. Assume that the totes are independent. Another key for recognizing binomial is to look for this word, independent. Okay. Determine the proportion of totes that from the supplier that must exceed 76. Okay. Determine the number of determine the proportion of totes from the supplier that must exceed the so that the probability is 0.9 that at least one tote in the sample fails. What is required? What is given? Read the highlighted information and see what is required, what is given in terms of X. I already defined X for you. The key is all here. When X has a binomial distribution, what are the two values in binomial distribution that you need to solve any question? What is N? No, not the value. What do we mean by N? Number of selections, right? Samples. Number of selections. What is P?
Probability of success.
Probability of success. Probability of what is success? That a sample exceeds. Okay, now keep this P definition in mind. Determine the probability of totes that must exceed the moisture content. What is this? The proportion or the probability of totes that exceed the content target is what? Is P. So what are you supposed to determine? What are you supposed to find in this question? P. Look at the highlighted blue thing. Determine the probability of a toad that exceeds the moisture content. P. Look at the definition of P. Probability or proportion, they are the same things. Read it again. Digest it. Don't read what is given. Read what is required. Determine the probability of toads from the supplier that must exceed the proportion, the moisture content, P. Determine the value of P such that, now read what is given, such that, what is given? Probability of something is 0.9, that is given. What is the probability of that? What is that something? At least one. Out of a sample, there is a problem here. It should be 10, maybe in the printing. It should be 10. How will you solve this question? 30, you cannot solve it if n is different. Yeah, you can solve n. Take n equals 30, but it should be 30 over there also. It should be consistent. The question should be 30, 30. 30, you can solve it with any n. N is given to be 10. Probability of x greater than or equal to 1 is given to be 0.9 and p is required. How will you solve this? Using binomial. Yes, x is binomial, but then what will be the procedure? Use complement. This is equal to, correct? Because there is no value in the binomial less than 0. Only value of x which is possible less than equal to 1 is 0. And this probability is 10 combination 0, p to the power 0, 1 minus p to the power 10. This is given to be 0.9, correct? Can we solve it for p? What is 10 combination 0? 10 choose 0. Calculators. It's 1. It's 1. What is p to the power 0? It's 1. So 1 minus p to the power 10 is 0.9. How can you solve this one? Calculus 1, Math 101. Log. No, not 101 even. 001. Log. So log of 1 minus p to the power 10 is log of this one. Then what? Use the property of the log. Log of a to the power b is what? Right? Divide both sides by 10. Take e to the power both sides. Take p to this side, p to this side, and e to this side. P will be right, and this will be equal to, see the magic, I'll do the calculation in mind, 0.2057, right? So this is a kind of similar question to this one, where we told you that x has a Poisson distribution, but we did not give you lambda. We gave you lambda in terms of probability of x equals 0 equals 0.4. And we asked you to find lambda from there. Similarly, in this question, we told you that x has a binomial distribution. We actually did not tell you, you recognize that x has a binomial distribution. This is even more difficult level question. You recognize that x has a binomial distribution, but you couldn't find p. Why you couldn't find p? Because p was not given. What was given was that probability of x less than equal to 1 is 0.9. Go and find P. So these were some of the A++ questions that I found in the exercises. I posted 25 questions in the exercise. These were 3 most difficult out of those 25 questions.